Problem 2. A triangle has side lengths A, and B. It has perimeter P and area A. Given that B and P are integers and that P is numerically equal to A squared, find all possible pairs A, B. So here's the setup. We have a triangle with lengths A, and B. So the perimeter is 2A plus B. And we know that the perimeter is equal to the area squared. We also know that P and B are integers. Well, one way to introduce the area is to look at this perpendicular height here, which I've labelled h. And we can use Pythagoras to get that h squared is equal to a squared minus a half b squared. And now we can look at a squared, and that is going to be b squared h squared over 4. And when we substitute this in and tidy it up a little bit, we're going to get 1 over 16 b squared times 4a squared minus b squared. So now we have the area squared, we can equate it to the perimeter and see what that gives us. So we've got 2a plus b is equal to 1 over 16 b squared times 4a squared minus b squared. We can multiply both sides by 16 just to get rid of that fraction. And you should always be on the lookout for difference of two squares. And here there is one. So we will factorize that. We know for sure that 2a plus b is not equal to 0, so we can divide by that. And now we have something that we can use. We know that b is an integer, so b squared is also an integer, and we can see here that b squared needs to divide 16. And that means that b must be equal to 1, 2, or 4, and there are no other possibilities. So we found that b had to be 1, 2, or 4, and we can create a table to find the values of a. So b squared follows automatically, and then by looking at this equation here, we can work out what 2a minus b must be, and then by using these, we can work out what a must be. And this gives us the three pairs, 17 over 2, 1, 3, 2, and 5 over 2, 4. Three possible pairs for A and B. And just to be certain, you do need to check that these pairs do give you genuine triangles. Another way to calculate the area is to use Heron's formula. Now, this is something that you may not have come across before. It isn't covered in school mathematics. But we use this S, which is the semi-perimeter. So that's the perimeter, A plus B plus C, for any triangle divided by 2. Then the area, according to Heron's formula, is the square root of S times S minus A times S minus B times S minus C. And we can use that on our triangle. So on our triangle, S would be equal to 2a plus b over 2, or a plus b over 2. And then we can calculate a squared as a plus b over 2, b over 2, b over 2, and a minus b over 2, which gives us 1 over 16, 2a plus b, b squared, 2a minus b. And we're in exactly the same position as we were before, so we'll get the same answers out.